Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Azman. I'm from class EE241 4B. So this is my lab report for lab 1. There is ARM assembly language programming, data transfer, data processing and addressing modes. So the objective for this lab is students should be able to write simple assembly language programs for the ARM microcontroller using data transfer and data processing instructions and addressing modes. Next is students should be able to execute the programs using an ARM kill editor, assembler and simulator. For question number 1, write a program that will store 0x30 into R0, copy the content of R0 into R5 and then save data 0x45785612 into memory location 0x40000030. Execute the program and explain the differences in the results. Also discuss the addressing modes of each instruction used. So as we can see here, uh, this is my simulation for question number 1 and this is my manual calculation for question number 1. So as we can see from the first line, I use MOV command to store the value of 0x30 into R0. So the next line is I use MOV command also to copy the value of R0 into R5. So the next line is I use LDR command to load 0x45785612 into R1. The next line is I use LDR command to load the value of 0x40000030 into R2. So the last line, I use STR command to store the value of R1 into R2 memory. So the first step of this program, it shows that the value of R0 will change into 0x3 0x0000030. So we can see that is the same. It's follow the first line here. So the next step is the value of R5 changes into 0x0000030. It's follow the second line here. So the next step is you can see that the value of R1 changes into 0x45785612. So it follow the third line here of the command. So the next step is the value of R2 changes into 0x40000030. This is the fourth line here. It follow the fourth line command here. So the last step is as we can see that the memory of 0x40000030 here see that is 1256785. This is because the value of R1 is the value of R1 is stored into is stored into R2 memory here. So this is for the value of value of 0x4000303132 and 33. So this is my manual calculation for question number 1. This is the first step. As you can see, that is the same same as the program for the first step. So the second step is also the same. So you can see that the value of R5 30 here. So the third step, you can see that the value of R1 changes into here. So you can see that the value of R1 changes, so same. So the value of R4 and the value of R2 change, same as the program here. So the last step, you can see that you can see that the last line here. So the value of R1 and R2. So we can see that this is the R2 memory and this is the value of R1. So the addressing mode for each instruction used. So the first instruction, the first instruction that I use is the for this instruction. This is immediate addressing mode. So the second instruction I use is register addressing mode. So the third instruction I use the immediate addressing mode also. So the fourth instruction I use immediate addressing mode also. So the last instruction is indirect addressing offset. So that is for question number 1. For question number 2, write and execute a program that will add 0x20FE5690, 0xFE123089, and 0x34589710, and save the sum in register R7. Record the changes in CPSR as well. So this is for simulation for question number 2, and this is for the manual calculation for question number 2. As we can see in the first line here, I use LDR command to load 0x20FE5690 into R1. So the next line is I use LDR command also to load 0xFE123089 into R2, and I use LDR command also to load 0x34589710 into R4. So the next line is I use ADDS command. This command it will add the value of R1 and R2, and it will store in R3. So then the last line I also use ADDS command. So it will add the value of R3 and R4, and it will store in R7. So uh, so we can go into the first step here. As we can see in the first step, the value of R1 changes into 0x20FE5690. This for the first line here. So the next step is the value of R2 changes into 0xFE123089. So this is the second line here. So the next step is the value of R4 changes into 0x34589710. So this is the third line here. Same. So the next line here is the value of R3 changes into 0x1F108719. So see this is the line the command. So we can see that this is the CPSR value. So we can see that the value of n equal to 0, z equal to 0, c equals to 1, and v equal to 0. Yes, we can see that the value of R3 have a carry. So this is because the have carry. So the value of C1 equals to 1. So next step is, as you can see that the value of R7 changes into 0x53691E229. As we can see here that the value of CPSR here is this for the value this the value of CPSR for the R7. So we can see that the value of n equal to 0, z equal to 0, c equals to 0, v equal to 0. The difference between the value of R3 and R7, we can see that the value of c here. So R3 has carry, so the value of C1 equals to 1, but the value of R7, yes, so the C equal to 0, so the value of R7 has no carry. So that is my simulation for the question number 2. So this is my manual calculation. So we can see that the first step here, the value of R1 here is the same as the simulation. So the second step here, the value of R2 here is the same as in the simulation. So the value of R4, the third step here, you can see that the value of R4 is same as the simulation here. So the fourth step here, as you can see that the here that the when I add the value of R1 and R2, the value of R3, this is the value of R3 here is same. So this why I explain the why this the explanation why the value of R3 has a carry here. So this is the before the addition, and this is the after addition. So we can see that the value of this have a carry. So the last step here is the addition of R3 and R4. So the value of R7 here is the same as the calculation here. So this is the explanation. This is the calculation. So we can see that the value of R7 here doesn't have carry. So this is the before calculation and this is the after calculation. So that is for question number 2. For question number 3, write a program that will store 0x2936FEDA in R8 and then perform the following instruction on the content of that register 4 times. Comment on your result. So for the question 3.1, we're gonna use ASR command. So this is my simulation for question 1, question 3.1, and this is my manual calculation for question 3.1. So The first line here, I use LDR command to load 0x2936FEDA into R8. So the next one, I use ASR R8 #4 because the question told me to follow the instruction on the content of that register 4 times. So so we move on into the simulation. So as we can see that the value of R8 changed into 0x2936FEDA. So this is the first line. So the next step is, as we can see, the value of R8 changed into 0x02936FED. So this is because of the ASR command, because the meaning of ASR command is arithmetic shift right. So I will further explain to you in my manual calculation. So the first step here, you can see that this is the before and after. So this is the before, the value of R8, and this is the after simulation. So the value of R8 changes into 02936 FEDA. This is the first line here. So the next is use the ASR command. So the before simulation, the value would be 2936 FEDA. So because of the ASR command, we need to erase the last 4 digit here and replace it with 00000 in front of the value. So the final value would be 02936 FED. So it will be the same with the simulation here. So that's it for question number 3.1. For question number 3.2, so the question asked me to use LSL command. So this is my simulation for question number 3.2, and this is my manual calculation for the number 3.2. So the first line here, I use LDR command to load 0x2936FEDA into R8. So the last line here, I use LSL command. So the meaning of LSL command is logical shift left. So I will go to the step here. So you can see that the value of R8 changes into 0x2936 FEDA. So is same as the first line here. Follow the first line here. So the next step is it will change the value of R8 changes into 0x936 FEDA 0. So so this is the simulation for question number 3.2. So I will explain further into my manual calculation here. So LSL is as the command for LSL is logical shift left. So this is the before execution of the program. So the value is 2936 FEDA. So after the execution of the program using LSS command, so the first four value in the front will erase, so it will replace into here into 0000 in the back of the new after the execution. So the final answer is the for the for this program, it would be 936FEDA0. So you can see that the manual calculation is the same with the simulation here. So that's it for question number 3.2. For question number 3.3, we gonna use the ROR as our command. So the first, this is my simulation for question number 3.3, and this is my manual calculation for question number 3.3. So the first line here, I use LDR command to load 0x2936FEDA into R8. So the next line here, I use ROR command R8 hashtag 4. This is because the question asked me to follow the instruction on the content of the register 4 times. So without further ado, I will go to the simulation of the program. So as we can see that the value of R8 changes into 0x2936FEDA. So this is the first line, this follow. So the next step is, you can see that the value of R8 changes into 0x A2936FED. So this is for the second line. So I will further explain to you how the final simulation get the answer for this one. So for for this question, ROR, the meaning of ROR command is rotate or right. So before the simulation here, the value of R8 would be 2936 FEDA. So this command will this command will take the last 4 digit to rotate into the front of the value. So the final answer, or the final answer would be, after execute the program, the final answer will be A2936FED. So you can see that the manual calculation is same with the simulation here. So that's it for question number 3.3. For question number 4, write a program that will perform logical OR 0x6398 with 0x1DFE. Execute the program and comment on the result. So as we can see here, this is my simulation for question number 4, and this is my manual calculation for question number 4. So as you can see, for the first line here, I use MOV command to store the value of 0x6398 into R1. The next line here, I use MOV command also uh, to store the value of 0x1DFE into R2. So the last line here, I use ORR R3, R1, and R2 because the question asked me to perform a logical OR. So, without further ado, I will execute the program here. As we can see, that the value of R1 changes into 0x00006398. Is same with the first command here, the first line here. So the next step is, the value of R2 changes into 0x0001DFE. So this is the second line here. So the next step is, the value of R3 changes into 0x000007FFE. So this is the simulation for question number 4. So the manual calculation here. So I will explain here for the my calculation, manual calculation here. So the value of R1 is the same with the simulation here. And the next step is the value of R2 is the same with the simulation here, and the value of R3 is the same with the simulation here. So if you don't uh, know how to get the value of R3, I will show you here. So you can see that we need to open the calculator here. So we need to use the hex number. So 6398. We need to use the OR because the question asks us to use the logical OR. So 1DFE. So you can see that the value is 7FFE. So it's the same with the value of R3 here. So that is for question number 4. For question number 5, write a program that copy 12 bytes of data starting from memory location 0x400400000H to memory locations starting 0x400020H. Set manually the content of memory in 0x40004000H until 0x40040000BH to be 0x01, 0x02, and so on. Run the program and comment on the result. So this is the simulation for question number 5. So you can see in the first line here, I use LDR command to load 0x400400000 into R0. And the next line is I use LDR command also to load 0x400400020 into R1. So the next line I use MOV command to, to store R2 counter with 3. So the next line here I use LDR command also. I use LDR command to load the value of R3 that memory pointed by R0 by post index 4. So the next line here I use str command to store the value of R3 that memory pointed by R1 by post index 4. So the next line here I use sub command to subtract the value of R2 with 1. So the next line here I use uh, cmp command to compare the value of R2 with 0. So uh, this before we run the program here, I just want to let you know that I manually key in the value in memory for 0x40004000 from 01 until 12. So current the program here. So you can see the first step here. You can see that the R0 changes into 0x4004000. So it is the first line here. So the next step is the value of R1 changes into 0x400400020 is the second one. So the next step is the value of R2 changes into 0x000003. over here. So next step is you can see that the value of R0 changes into 0x40040004. Uh, this because the value of R3, that memory pointed by R0, value of readable by R0 is post indexed by 4. So we can see that the value is changed, and this we can see that the memory here also highlighted from 01 until 02 04. So we can go to the next step here. You can see that the value of R1, or before that, I missed that the value of R3 also changes into 0x 04030201. So this is because the value of R3, the memory pointed by R0 here. So the next is the value of R1 changes into 0x40040024. So you can see that here that the value of R3, that memory pointed by R1, is post indexed by 4. So this is the for this for the value of R1 here. So the next step is see that this the value of R2 changes into 0x000002. So the value of R2 is not equal to 0, so it will repeat again. It will repeat the process back to it. So go to the next program. So you can see that the value of R0 changes into 0x40040008, and the value of R3 changes into 0x08070605. We can see that the memory you can see that the value of R3, the memory pointed by R0 by post index 4. So we can see that uh, the value of R3 changes from 05 until 08 here. So the next step is so the value R1 changes into 0x40040028. So you can see that the value of R1 here, you can see that the value is 05 until 08. So we go to the next step. So the value of R2 changes into 0x00000001. So the value of R2 is still not equal to 0. So it will repeat again the process of the program. So we go to the next step. So we can see that the value of R0 changes into 0x400400C. So and the value of R3 changes into 0x12111009. We can see that the value of R3, that memory pointed by R0 by 4 index by post index 4. Index 4. You can see that the value of R3 is taken by the value of by from 09 until 09 until 12. So we go to the next step. You can see that the value of R1 changes into 0x40040002C. you can see that the value of R3 that memory pointed by R1 was indexed by 4. See that? From 09 until 012. So we go to the next step. So the value of R1, the value of R2 changes into 0 at 000000. So you can see, so the value of R2 equals to 0. So so the process will be, that is the process of the simulation of this program. So that is for question number 5. For question number 6, write a program to compare data in num into register R2. If the data is greater than 5, store the data in memory location 0x400200000. Otherwise, add the data with 0x60 and store it in memory location 0x400200010. Before that, set the number with value 3, use EQ instruction, run the program and comment on the result. So this is my simulation for question number 6. So the first line here, I use LDR command to load 0x400200000. The second line here, I use LDR command 2 to load 0x400200010 into R1. So the next line I use MOV command to store the value of 0x05 into R2, and the next line I use MOV command 2 to store the value of branch num into the value R3, and the value of num is 3 because the question asks to do so. So the next uh, line is I use CMP command to compare the value between R3 and R2. So the next line is I use BHI command. BHI stands for higher related into branch bigger. So when the number that have been compared between R3 and R2, so if the value of the R3 is bigger than R2, it will straight to the STRB. So it will store byte size into value of R3 memory pointed by R0. If it's not, it will go to the next line here. So the next line here I use add command. So to add R3 with 0x60, and it will store into R4. So the next line here I use strb to store byte size of the value into R4 memory pointed into R1 by R1. So without further ado, I will go to the simulation. So you can see that the value of R0 is the same with the first line here. So the next step is the value of R1 here is the same with the value the next line here. So the next step is the value of R2 is changed into 0x000005 here. So the next step is the value of R3 is 0x000003 here. So the next step is, so you can see that the value of R3 is smaller compared to R2. So the the addition command has been used to by R3 add by 0x60. So the next step is, as we can see that from the memory here, you can see that the value of 63 has been stored into uh, the byte size of the value into R4 memory pointer in by R1. So you can see that from here. So that's it for that's it for question number 6. So to conclude the lab that I have been given, so student will able to apply what that have been learned with their lecturer in the class. So the topic that apply to this lab is ARM microprocessor architecture, arithmetic operation on assembling language, logical instruction, shift and rotate, loop and branch. So uh, moreover, student able to write simple that program data transfer and data processing instruction, also addressing modes. So last but not least, be student able to execute the program using simulation on software kill microvision to verify the answer correctly, to ensure that manually calculation is the same as simulation. So that's all from me. Thank you.